this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet Slope. And our directions for our first set of problems are to find the slope of each line. And before we really dive in, let's just talk about what slope is. Slope, essentially, you can think of is as the steepness of the line. Imagine it as a hill. As we move to the right, the slope can either be positive, meaning we're moving upwards. It could be negative, meaning we're moving downwards. It can be zero, essentially meaning that we're not changing our elevation. Or if we're not moving at all to the left or right, that slope is undefined. So looking at number one, we can tell right away that the slope is going to be what? Is it going to be positive? Are we going upwards as we move to the right? Or is it going to be negative? Are we moving downwards? It's going to be negative. So we know we have a negative slope in number one. But what exactly is that value, besides the fact that it's negative? Well, slope is the change in y over the change in x, the rise over the run. So if we look at this, our rise between our points, to get from this point here to this point here, we have to go down one. So going down one in our rise, that's a negative 1. And then we're now at this point here. How do we go from that point to get to our other point? We go over to the right 3. 1, 2, 3. So our rise is down 1, so that's a negative 1. And then we go to the right 3, that's a positive 3. So our slope is rise over run, negative 1 over 3. So just as we talked about, it is indeed negative, and our change in y between points is 1, and our change in x is 3. Negative 1/3 is our solution in number 1. Let's go over this again in number 2. For number 2, let's think, is our slope positive or negative? Well, as we move to the right, our line goes up. That means our slope is positive. And we can also see that from the numbers we'll calculate. Remember, slope is rise over run. How far we change vertically over how far we change horizontally. So looking at our vertical change, we need to go up 1, 2, 3 to be on the same level as that next point, and we need to go over 1. So going 3 up and over 1, that's a rise of 3 over 1. And it was a positive rise and a positive direction we move to the right. 3 over 1, that's just equal to 3. So our slope in number 2 is a positive 3. Let's move on to number 3. In number 3, right away, we can see that our slope is negative because we're going down as we're moving to the right for our coordinate system. And again, we can see it's negative if we calculate the rise over the run. How far we move vertically, up and down, over how far we moved left or right. So we're going to go down 1, 2, 3. That's a negative 3. And we're going to go over 2. 1, 2. So our rise is negative 3 over our run of 2. That's negative 3 halves for our slope. And in order to double check, let's take a look. Negative 3 halves is, in decimal form, negative 1.5. So if we're starting at this point here, and we move over, let me switch colors. If we're starting at this point here and we move over 1, our slope tells us how far we're moving down. As we move to the right 1 unit, we're moving down 3 halves or 1.5 units. So you can see there's my 1 and there's my extra 0.5 to right here. So you can double check your slope by moving 1 unit over and making sure that you're moving the appropriate length in the rise. Let's go on to number 4. Number 4, we can see that we have indeed a positive slope. Rise over run. If we go up 1, 2, 3 and over 1, 2, we'll get to our point. Rise, the change in y, over run, the change in x. So that's a positive 3/2 for our slope in number 4. And again, to double check, if we were to move 1 unit over, we should move our slope in that y direction. So going up 1.5, that is my 3/2. Let's move on to number 5. Number 5, we can see that our slope is, well, as we move to the right, our line is going up. So it's a positive slope. Now we're going to calculate rise over run. To get from this point to this point, we have to move up 1, 2, 3, 4, 5. So that's 5 up. And how many over? 1, 2, 3 over. Rise over run, that's going to be 5 over 3, or 5/3 for our slope. Now, think about if you calculate this a little bit differently. Going over 1, 2, 3, that's your run, and then up 1, 2, 3, 4, 5, there's your rise. So going either direction to get to your point, calculating going horizontally first or vertically first, doesn't matter as long as your rise is over your run. So that 5 goes over the 3 when we write out our slope. Let's think about this from one other way. What happens if we started at our rightmost point to get to our leftmost point? Well, then we would be going 1, 2, 3, 4, 5 down. That would result in a -5 because we're moving down. And 1, 2, 3 to the left, that would be a -3. But look, -5 over a -3 is still a positive 5/3 because a negative over a negative is still a positive. Let's move on to number 6. In number 6, we can see right away that we have a positive slope. We just have to calculate that positive slope. Just try the run first. We go 1, 2, 3 over in our run. Remember, that's our denominator. And then 1, 2, 3, 4, 5, 6, 7 up. That's our rise, so that's our numerator. 7/3 is our slope for number 6. Moving on to number 7, we have a negative slope because our line is going down as we move to the right. So if we think about on a hill and we're starting up here, we're going to go down the hill as opposed to going up the hill. So let's calculate our rise over run. Starting with our leftmost point, we're going to go down 1, 2, 3, 4, 5, 6. Going down, that's a -6 or a change in 6. And then over 2, 1, 2. That's a positive 2 because we're moving to the right. So that's a -6/2, which is equal to -3 when you simplify that fraction down for our slope in number 7. Let's move on to number 8. Now number 8, calculating it the same way, rise over run. Our rise, we have to go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3. So this is a slope of 7/3 for number 8. And it is indeed positive because as we go to the right, we're going up. But let me show you one more method that's going to help us on this second page. Let's say we just labeled these points. This point here, you can see is 0 in the x and 3 in the y. So that's 0, 3. That's that coordinate. And this point over here is a -3. See, we're going backwards 3 from that x-axis. So that's a -3. And it's down 1, 2, 3, 4 from our y-axis. So -3, -4 is this point here. We can calculate the slope without even seeing this line. If we didn't have this line at all, but we knew those coordinates, we would be able to calculate the slope. Remember, it's rise over run, change in y over change in x. How far we're changing vertically over how far we're changing horizontally. So let me rewrite these points over here. One point is 0, 3, and the next point is -3, -4. So if I take the change in y the difference over the change in x, the difference in x, I'm going to be able to calculate my slope. So let's go ahead and start with this point here. And it doesn't matter what point you start with as long as you're subtracting the same way. And what I mean by that is if we're taking this y and subtracting this y, we need to take this x and subtract this x. We can't reverse that and start with this and then subtract that. We have to go the same way. So starting with our change in y, we're going to have 3 minus a negative 4, and that's going to be divided by 0, because that's the coordinate that goes with a 3, minus a negative 3. 3 minus a negative 4 is 3 plus 4, which is 7. 0 minus a negative 3 is 0 plus 3, which is a positive 3. So you can see we do indeed get 7/3. And that was without knowing anything over here besides the points. So that leads us right into our second page. Our directions for this are to find the slope of the line through each pair of points. Rise over run, change in y. Over change in x, we just have to make sure we're keeping the subtraction consistent. So quickly, I'm going to take some time and do it 2 separate ways in number 9. Feel free to just follow me for the first way and then move on. But let's start with this point here. If I'm starting this with this point here, I need to start with my y values and my x values and subtract this other point. So I'm going to start with 10 and subtract my y value of 14. I need to start with 8 and subtract my x value of negative 7. That's one way to do it. Or my second way, I can start with 14 and subtract 10, and then start with negative 7 and subtract 8. If you're doing it right, you should see your xy values in line. Here's my yx coordinates. Here's my yx coordinates. And same over here. Now working this out, I'm going to show you that either way gives you the same result. Change in y, make sure to have those y coordinates in the numerator, and change in x, those x coordinates in the denominator. 10 minus 14 gives us a negative 4 over 8 minus a negative 7. That's 8 plus 7, which is a positive 15. So we get negative 4/15. Let's move over to this next expression we set up. 14 minus 10, that's a positive 4. But look, in our denominator, negative 7 minus 8 is a negative 15, which is still going to give us a negative 4/15 for our solution. So just remember, make sure you're subtracting the same way, y of one point minus y of another, x of that original point minus x of the other. Let's continue on to number 10. Starting with my first point, I'm going to take that y value of 1 and subtract the other point's y value of 2 and divide that by the first point's x coordinate of negative 3 minus the second point's x coordinate of negative 17. 1 minus 2 gives me a negative 1. All over negative 3 minus a negative 17 is negative 3 plus 17, which is a positive 14. So negative 1/14 is my slope in number 10. That means going down 1 and over 14 will take me from my leftmost point to my rightmost point. Think about it. This is the leftmost point since the x is the furthest over. If I go down 1, I get 1. And then if I go over positive 14, I get to that negative 3. For number 11, starting with this coordinate here, I'm going to have my y value of negative 4 and subtract my other y value of negative 10. Doing the same subtraction order, I'm going to start with my leftmost coordinate here of negative 20 and subtract my negative 12. And it is subtraction when we're doing this. We're finding the change, so the difference. Negative 4 minus a negative 10 is negative 4 plus 10, which gives us 6. Negative 20 minus 12 is negative 20 plus 12, which gives us a negative 8. So this is negative 6/8, which is equal to, think about, both are divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Keep that negative out in front. Negative 3/4. Let's move on to number 12. Starting with this point, negative 12, negative 5, going to 0, negative 8. Let's just do this one thinking about it. How do we get from our y value of negative 5 to our y value of negative 8? We have to go down 3. So that's a negative 3 in the rise. How do we go from our x value of negative 12 to our x value of 0? We have to go over a positive 12. So this is negative 3/12 or negative 1/4 when simplified down, since 3 and 12 are both divisible by 3. Think, negative 8 minus a negative 5 is a negative 3. 0 minus a negative 12 is a positive 12. Let's continue on to number 13. Change in y over change in x. And I'll go ahead and start with this rightmost coordinate just to switch it up. So we're going to do 16 minus a negative 6 all over 15 minus a negative 19. 16 minus a negative 6, that's 16 plus 6, which gives us 22. 15 minus a negative 19 is 15 plus 19, which gives us a positive 34. 22 divided by 2 is 11, and 34 divided by 2 is 17. So that's 11/17 for our simplified fraction in number 13. In number 14, pick a coordinate to start with. I'll start with this first one here. So I'm going to have 9, which is my y value, and I'm going to subtract a negative 9, my other coordinate's y value. That's going to get divided by negative 6 minus my other coordinate's x value of 7. 9 minus a negative 9 is 9 plus 9, which is a positive 18, and that's all over negative 6 minus 7 is a negative 13. So this is going to be negative 18/13. Can't simplify that down anymore, so that's our solution in number 14. For number 15, starting with this coordinate here, we're going to have the y value of negative 20 minus the y value of our other coordinate of negative 15. And we're going to divide that by our x value of the first coordinate, negative 18, minus the x value of our other coordinate, negative 18. Negative 20 minus a negative 15, negative 20 plus 15 is a negative 5, and then we have negative 18 minus a negative 18, that's negative 18 plus 18, which is 0. But wait a second, we have an issue here, because we can't divide by 0. That is undefined. So our slope in number 15 is undefined. And what does that mean? Let's think about this on a coordinate system. We have the point negative 18, negative 20, somewhere over here, and the point negative 18, negative 15. That negative 18, that value for x, is the same. So if I was to draw a line and connect those 2 points, I would have a vertical line. What's the slope of a vertical line? Well, we aren't moving right or left, so we don't know what the change in that y value is. It's undefined. That's why our slope of a vertical line, we can say, is undefined. This line, in other words, could be written as x equals a negative 18. That is this line that I've pictured here. Let's move on to number 16. Number 16, we have, I'll start with the second coordinate, just for fun. Change in y, we'll start with the value of 12 and subtract negative 18. So we'll have 12 minus a negative 18, and then we'll divide that by, starting with that same coordinate we had started with, just using the x value now, that's 11 minus 12. 12 minus a negative 18 is 12 plus 18, which gives us a positive 30, and 11 minus 12 is a negative 1. 30 divided by negative 1 is negative 30, which this is a pretty steep slope if we think about it. For every 1 unit we move to the right, we're going 30 units down. That's a very large negative slope. A good piece of advice whenever you're doing these problems is just to visualize what it is, or at least understand what you're solving for. Because that negative 30 slope is a lot more steep going downwards than if we were to scroll up and look at that number 12, that slope of negative 1/4. Those are dramatically different slopes. Or even that negative 1/14, which is even smaller. Let's move on to number 17. And for number 17 and the rest of this worksheet, it simply says to find the slope of each line, and we're given an equation. So when we're given an equation, in order to easily identify the slope, we want it in the form of y equals m times x plus b, where this m and b are just a coefficient and a constant, and our x and y are variables. What this tells us is our m is the slope of the line, so that's what we want to look for this worksheet, and our b is the y-intercept. And our y-intercept is where we cross that y-axis. So if you ever have an equation in this form, it should be easy to draw the line, or if you ever have a line, it should be easy to write this equation. Let's go back up and look at number 2 and how this relates. If we look at number 2, if we were to write this equation, y equals m, which we're going to figure out is our slope, times x plus b, our y-intercept. So mx plus b. Our m, in this case, we already solved, was a positive 3. So I'm just going to go ahead and fill that in. So we have y equals 3x plus, what's our y-intercept? Our y-intercept is where we cross the y-axis, which obviously occurs at x equals 0 because that is the y-axis, and that y value is a negative 1. We're crossing this y-axis when x equals 0. We're crossing that at a y value of negative 1. So this is 3x plus negative 1, or we could write it as 3x minus 1. That is our equation of our line in number 2. Our slope is 3, our y-intercept is a negative 1. So diving back into number 17, if we just have to find the slope, we can easily see that our slope is multiplied by that x, because we are indeed in the form of y equals mx plus b. That slope is a negative 5. So if we were to draw this line, just a quick sketch of it, I know that my slope is a negative 5, so I'm going down and I'm intercepting the x-axis. If we have to add b, we're adding a negative 1. So I know that I have a point 0, negative 1 here, and my slope is negative 5. This is just a rough sketch since I don't have any labels, but this is how you can quickly form those lines. Let's move on to number 18. Number 18, are we in the form of y equals mx plus b? Yep, y equals 1/3 x plus a negative 4, or minus a 4. So our slope is right here, that 1/3. Let's move on to number 19. Number 19, are we in the form of y equals mx plus b? Yep, we sure are. So right here is our slope, negative 1/5. Moving on to number 20. Ooh, number 20 is a bit trickier. We talked about this in number 15 though. We're not in the form of y equals mx plus b. You can see there's no y at all in this equation. There is absolutely no y, which means this is just a vertical line. And what did we say about a vertical line? The slope was undefined. So undefined is our answer for number 20. Speeding right along to number 21, y equals 1/4 x plus 1. Our y-intercept is 1, so we're intersecting that y-axis, x equals 0, at a positive 1, and our slope is 1/4. Change in y over change in x. For every 1 we go to the right, we go 1/4 up. Rise of 1 over a run of 4. 22, we can see that our slope is multiplied by that x, negative 2/3. Moving right along to number 23, y equals negative x plus 2. what's our slope? What's multiplied by that x? It's a -1. So our slope is -1 for number 23. So if we wanted to quickly sketch this one out, draw our coordinates, x, y, +2 is our y-intercept. So when x is 0, that y-axis, we're intersecting at a +2, and our slope is a -1. So for every one we go over, we go down 1. I can quickly graph another point here, and there we go. So that's just how we could expand upon this equation. This one little equation tells us a whole lot about a line. For number 24, we basically have the same thing as number 23. Our slope is a -1 because that -1 is multiplied with x. Mx plus b, m is -1. Number 25, what's our slope? Well, what's multiplied by x? A 2. But that is not our slope. Why is 2 not our slope? Because we're not in the form of y equals mx plus b. We need to be in this form in order to figure out our slope. So let's solve our equation for y. We need to isolate y, get it all by itself, so we're going to have to move this 2x to the other side. So we'll do so by subtracting 2x. So we have 3y equals 9 minus 2x. We're almost done. We need that y by itself, so we have to divide by 3. And when we divide by 3, we divide on both sides. 3 divided by 3 is 1. 1 times y is just y. So there's our y. And that equals, this 3, remember, when we divide, is applied to both the terms in our numerator. So 9 divided by 3 is 3, minus 2x over 3, so that's minus a 2/3 x. Now you may be confused here, because it doesn't quite look like y equals mx plus b, but we can easily switch these up. Since we just have subtraction, I can rewrite this as y equals a -2/3 x plus 3. This is the same thing. All I did was move this term out in front and brought this term to the back. But this term was negative where this term was positive. So I have to remember to keep that negative and positive as is. So we can see that my y-intercept, where I'm intercepting that y-axis, is 3, and my slope is -2/3. So again, -2/3 is my slope for number 25. Number 26, we're going to have to do the same thing because you see here, we don't have it in the form of y equals mx plus b. So we got to get there. Let's start by moving this 5x to the other side. So we'll subtract 5x. That's going to give us that 2y equals 6 minus 5x. All we have to do left is divide by that +2 to both my terms, because 2 divided by 2 is 1. 1 times y is y. And that's equal to 6 divided by 2, which is 3, minus 5x over 2, which is 5/2 x. So I'm not going to switch these terms up because we know that our slope is what's multiplied, that coefficient that's multiplied to x. And in this case, it's subtracted. So you can see here that our m is a -5/2. So -5/2 is our final solution on this worksheet. If you have any questions at all, please feel free to leave them in the comments below, and I or one of your peers will reply as soon as we can. Also, if you found this video helpful, don't forget to click that thumbs up button and share it with somebody else that you think would find helpful. And again, in order to get this free worksheet, I'll leave a link in the description below. But as always, don't forget to like, subscribe, and share. Happy learning!